Okay, problems 21 and 22. We're working with some geometry. So first thing you need to realize is this is an isosceles triangle. So this angle, 43, has a measure of 43 degrees, angle P, is the same measure as angle T. So that one's 43. Then if I add these two together, I get 86. Subtracted from 180 makes this angle 94. These two are vertical, so that's 94. Then I can use the sum of the angles in the triangle. So I added up all of my angles equals 180. So I get 5x plus 95 equals 180. Solving for x, I get x equals 17. But make sure you read the question. It says, what's the measure of angle PGA? So I got to do angle PGA. So PGA is going to be 2x minus 3. So 2 times 17 minus 3 makes it 31. Therefore, my answer was C. Okay, now I want to find the measure of angle RED. So they told you that NE bisects MET. Well, if NE bisects MET, this angle right here is equal to this angle right there. So that means this one's also 2x plus 4. Now if I take these three and add them together, I get a straight angle. So I end up getting 2x plus 4 plus 2x plus 4 plus 64 equals 180. So I get 4x plus 72 equals 180. Solving for x, I get 27. We want to know the measure of angle RED. Well, that is vertical to this one. So RED is going to have the same measure as an angle NET. So it's just going to be 2 times x plus 4. So 2 times 27 plus 4 is 58. Therefore, the answer was D. Okay, problem number 23, 24, and 25. Okay, we're going to look at all the polygons that have at least 2 pairs of parallel sides. Well, a trapezoid only has 1 pair of parallel sides. Does not have 2. So that one's gone. That one's gone. Pentagon has 5 sides. Nothing's parallel. So therefore, it leaves us just with A and D. Anything that's a parallelogram will work. So rhombus and rectangle both work. Okay, on this one right here, we have to figure out what's possible lengths we could have for PR. So in this triangle. Well, the key thing is the sum of the 2 smaller sides have to be bigger than the longest side. So if I took A, I'd have 8 plus 4, that equals 12. That will actually form a straight line. So A does not work. 2 smallest, if I had 8 and 5, that equals 13. That's longer than 12, so that one works. Now I'm going to use the one with 10. My 2 smallest sides are 8 and 10. So 8 plus 10 is equal to 18. That's definitely bigger than 12. Now I go over here with 20. I got to take my 2 smallest sides. Now my 2 smallest sides are 8 and 12. This equals 20, so this will form a straight line. So the ones that the correct answers would be B and C. Okay, for this next one, the best way to do is draw a picture. So I'm just going to make up a picture, call this angle A, which was 68. Angle B, I'll put down the bottom, is 52. Then I use sum of the angles in a triangle. 68 plus 52 equals 120. Subtract that from 180, we get 60. And that's the measure of angle C. Your smallest side is opposite the smallest angle. So my smallest is this side. That's the smallest. So AC has to be one of the front ones. So I can get rid of him, him, and him. Okay, my longest side is opposite the biggest angle. So BC, this is the largest. So my largest one is going to be BC. That's this one, not this one. So therefore my answer was D. Okay, here's our proof problem. So now we're going to go through and work with this one. It's a little bit different because you're going to have to fill in some multiple reasons on some of the steps. We're given that CM is the perpendicular bisector of AB. That was given. We use the definition of perpendicular to show that these two angles down here at M were 90 degrees. I'll fill those in a little bit. Then they asked you, why is AM congruent to BM? Well, if we bisect, these two pieces are going to be equal. This comes straight from the definition of bisect. So the reason for 26 would have been C. For 27, we want to figure out why is triangle ACM congruent to triangle BCM? Well, fill in the information we have. That's from the definition of bisect. This is from our right angles. This is from reflexive. I've got side, angle, side. So it should be side, angle, side. Now we're getting down to the last two steps. Now we're trying to prove this, that CM bisects ACB. So that's what my final line is here. The way we're going to do this is basically we're going to have to use a definition. My last rule is going to be by the definition of bisect. So for problem number 29, my answers for 29, lost my mouse, there it is going to be definition of bisect and our last statement. So this is what you'd be bubbling for that last one, A and B. Okay, now in order to get to that, I'm going to use my congruence and use corresponding parts of congruent triangles to finish off this part. So if this is going to be true, if I'm going to show that CM bisects this angle, I've got to show that this angle here is equal to this angle here. That comes from CPCTC, or congruent triangles gives you congruent parts. So the answer for 28 would have been C and E. Okay, problem number 30. This is about building up your triangles. So first mark the things that are given. JL is congruent to PR. So JL congruent to PR. KL is congruent to QR. KL, QR. I want to see which ways I can make these congruent. Now, they'll be congruent if I need one more piece. You need 3 pieces to show congruence. Well, we have our choices. We have side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse like. There's no right angle, so this one's definitely gone. Okay, I've already got 2 sides, so I'm going to be using one of those 2. So either I get the third side, which is JK is congruent to PQ, or I have to get the one with the angle in between. The angle in between would be angle L equaling angle R. So I want to make sure I match up my correct ones. Angle L and angle R. Okay, that completes this part. Next video will be problems 31 through 40.